In this video, we will be looking at a few different slope properties, like direction, steepness, and if lines are parallel or perpendicular. So we'll start off with direction. So I have 4 lines on this graph, and we're just gonna sort them as traveling upwards or downwards. And when I say upwards or downwards, I do mean like reading the graph from left to right. So the ones that are going upwards would be the red line and the green line. So if I write down their equations, y equals 2x plus 3 and y equals 5 over 3x minus 6. The ones going down are the purple and the blue. So y equals negative x plus 6 and y equals negative 2 over 3x minus 1. Now, what we should notice about the slopes and the direction is that the lines that travel upwards all have a positive slope, whereas the ones that are traveling downwards have a negative slope. So positive slope equals up, negative slope equals down. And again, the slope is the value in front of the x. All right, so that's direction. Next, let's look at steepness. So we're going to rank these lines from least steep to most steep. So the least steep line, or the flattest line, is probably the purple one. So y equals negative 1 over 5x plus 6. Next, after that, it would probably be the blue or the red line, and I'm thinking that the red one is less steep. So y equals x plus 3. Next, that blue one, negative 3x minus 1. And then the most steep is definitely y equals 8x minus 20. Now, notice in all of these, the direction, whether it was going up or down, didn't affect the steepness. It was really just how flat or how steep it was, not the direction. So what I want to look at is the number 1 over 5, 1, 3, and 8. I'm ignoring the signs. And if I look at these numbers, the least steep slope had the smallest, and the most steep had the largest. So the steeper the slope, the bigger the number, the more shallow the line, the smaller the number. So steeper equals higher slope, shallow equals smaller slope. All right, so direction, positive for up, negative for down, steepness, ignoring that sign, the bigger the number, the steeper the line. Our final part is about parallel and perpendicular lines. So if you look at this first graph here, all of the lines are going in the exact same direction, which means they are all parallel. So they will never intersect because they're going in that same direction. And if they're going in the same direction, it means that they should probably be rising and running the exact same amount. So if we look at the slope in each scenario, 2, 2, 2, and 2, all the slopes are the exact same, which makes sense because their direction is the exact same. And here, the sign does matter. If I had a line that was y equals negative 2x, it's not going to be parallel because it's going in the opposite direction. All right, let's look at our next diagram. Here, you will see this little notation where the 2 lines intersect. That's a 90-degree angle, a right angle. That means that these 2 lines are perpendicular. Now, let's look at their slopes. This blue line has a slope of negative 0.5. This green line has a slope of 2, which I'll just write as 2 over 1. Now, some differences between the slopes. They're obviously not the same. One's positive, one's negative, and then the fractions look like almost the same except they've been flipped. So I'm going to make a note of that. So different sign plus flipped fraction. And that's it. And that we call an opposite reciprocal. So let's take these three properties and summarize them. Lines move upwards when the slope is positive. Lines move downwards when the slope is negative. When we ignore the sign, the larger the slope, the steeper the line. So those two kind of should make some logical sense. Next, same slope means same direction, so our lines are parallel. If the slopes are opposite reciprocals, so opposite meaning opposite sign and reciprocal meaning flip the fraction, we have perpendicular lines. So let's take these properties and put them into action. So in number one, we're going to state the direction of each of the following lines, just up or down. So my first slope is -3. It's negative, so it means the line must go down. The next one is +1/2. Positive means we're going up. Fill in the next two, pause the video, then come back. All right, so the next one, we have a negative slope, so it's down. And the last one, it's a positive in front, so it is up. All right, and the next one, we have 4 lines, and we have to rank them in order of increasing steepness. Now, I see some of them are in fraction form. So first thing I'm going to do is replace that -3/4 as a decimal. So 3 divided by 4 is 0.75. So the slope is -0.75 for this one. And now I'm just going to look at the slopes. The smallest number will be the least steep and the largest will be the most steep. And again, I'm going to ignore the negatives. Now, one more thing I'm going to do is in front of that -x, I'll put the 1. So the slope is -1. All right. So I'm going to look at 0.2, the 4, the 0.75, and the 1 to compare. Notice I didn't care about the negatives at all. So the smallest number is the 0.2. So that is the least steep. Next after that is the 0.75, then the 1, then the 4x. And there it is. All right, let's go to the next one. I'm going to replace the fractions with decimals. So 1/4 is 0.25. The 2 is fine the way it is. I have another -0.75. I have the 4. And then 5/2 is 2.5. So I want you to pause the video, compare your slopes, and rank them. Then come back to the video and check your work. All right, so the least steep was the first equation, y equals 1/4 x plus 3. Next, we would go to y equals -3/4x minus 1. Next, y equals 2x. Next, y equals 5/2x plus 1. And finally, y equals 4x. All right. So there's direction, there's steepness, and finally, let's look at some parallel and perpendicular slopes. So in this chart, I have 5 different slopes for us. We're going to determine the parallel and the perpendicular slope for each. So first we have 2/3. If I want a parallel slope, it has to be the same direction, which means I copy paste the slope. It's the exact same, 2/3. If I want the perpendicular slope, I'm first going to flip my fraction. So instead of 2/3, I'm going to write 3/2. But also, my original slope was positive, so this one must be negative. Okay, the next one. The slope is -4. So parallel will also be -4. Now, when I take my perpendicular slope, I know I need a fraction to flip, so I'm going to take that slope and put it over 1. Now, when I flip my fraction, I'm ignoring the sign right now. I'm just looking at the 4/1. When I flip it, it becomes 1/4. The original slope was negative, which means my perpendicular slope will be positive. So there it is, 1/4. make sure your slopes are opposite signs, or else they will not intersect at that 90 degree. They have to go in different directions in order for that to occur. All right, we have -3/4. Write down your parallel slope. Hopefully you wrote -3/4, the exact same. All right, write down your perpendicular slope. So hopefully you flip the fraction. So instead of 3/4, we have 4/3. The original sign was negative, so our perpendicular slope will be positive. So if you have 4/3, very good. If not, see where you went wrong. Don't make that mistake next time. Okay, our next slope is 2, so write down your parallel slope. Hopefully you wrote 2. For the perpendicular, you might want to write 2/1, and now go ahead, write that opposite reciprocal. So the reciprocal of 2/1 is 1/2. The original sign was positive, so our perpendicular slope will be negative. And finally, a slope of 0. For the parallel, it's going to be the exact same. For the perpendicular, when I put the 0/1 and I do my regular opposite reciprocal, the reciprocal is 1/0, and then I could put a negative. But here's the thing. If you try to take any number and divide it by 0, you're going to get an error. So I do not want to see this as a slope because it's not a number. It doesn't work. You cannot divide by 0. So we say that this slope is undefined. So I'm going to make a little note here. Can't divide by 0. 0 can be on top, but it can't be in the denominator. All right, let's try a few more examples here. We want to write the equation of the line that is perpendicular to this equation and has a y-intercept of 8. Okay, well, that y-intercept of 8, that means b is equal to 8. Now, for the slope part, they said perpendicular, so the original slope here is 5/8. My perpendicular slope is going to be, flip the fraction to 8/5, and then change from positive to negative. So now I can take these two pieces of information and put them into y equals mx plus b. So y equals -8/5x. The y-intercept is 8. There it is. All right. Write the equation of the line that is parallel to y equals -6x plus 1 and has the same y-intercept as y equals 2x plus 12. Okay, well, parallel means same slope, which means my slope is going to be -6. I don't even have to do anything. And if I want the same y-intercept, I know the y-intercept is always the constant, and the constant is 12. So b is 12. Now let's merge it together. Y equals mx, so -6x plus b, so plus 12. All right, final one. Write the equation of the line that is perpendicular to y equals -5x minus 3 and has the same y-intercept as y equals 3x minus 6. Pause the video, give it a try your best, and then come back to check your work. All right, so the original slope is -5, but I want the perpendicular. So remember, -5 is just -5/1. When I flip the fraction, 5/1 will become 1/5, and the sign is going to go from negative to positive. So there it is. If I want the same y-intercept as the second equation, that's the constant. I couldn't care less about this first portion. I could cross it out. And now let's put it together. Y equals my slope times x plus the y-intercept, but my y-intercept is -6. So here we are. And that's it. So lines going up have a positive slope, lines going down have a negative slope. The bigger the slope, ignoring the sign, the more steep the line. And finally, parallel lines have the exact same slope. Perpendicular lines, we flip the fraction and change the sign to get that opposite reciprocal.